Disruptors and curious minds, welcome to another episode of Thinking on Paper, your personal vehicle to understand the intersection of emerging technologies and culture, business, relationships, family, what it means to be human, what this technology is doing to affect us. My name's Jeremy. This is Mark. We're writers, we're curious minds. We're trying to figure all this stuff out. Here we are today. Mark, it's a new year. We've got some great segments coming up. We've got 3 new segments to the show. We're trying to be a little more organized, a little more intentional. So stay tuned for these new segments. It's going to be a blast. I'm excited. Mark, what are we learning about today?
I'm excited too. Yeah, new year, same awesome show. Artificial intelligence, AI. So every AI product you use, every service you use, it begins with machine learning engineers. But there's a problem. There are only about 300,000 of them worldwide, and maybe only a fraction of those are actually good, like 600 who can actually change and engineer meaningful products. Why is that? That's what we're asking today. Why are there so few engineers when all eyes are on AI? Is it because it's beyond most? Is it because it's too cumbersome? Dare I say it, unenjoyable? Is there too much upfront grunt work? What is the problem? And today's guests are going to give us a solution to the challenge. So, yeah.
That sounds like a good focus. We'll take good notes and stay tuned for the very end of this show. We're actually going to unpack our immediate insights for what we learned today because we're here to learn as well. So, Mark, who do we have on today, and where are they from, and where are we headed?
Well, this might be a first. Myself, I have 2 brothers. I'm a middle child, and today's guests are brothers, Saurabh and Gaurav Vij, and I'll let them explain where they are. I think they're in different continents. Maybe that's a brother thing to keep working together. I don't know, but find out. But welcome to the show.
Hi guys,
Hi.
Thanks for
for
being
having us.
and
I'm dialing in from Canada, Toronto. We just had a snowstorm, so yeah.
Yeah,
We
I'm
we
calling
have
in from New Delhi, India.
where you haven't had a snowstorm.
No, absolutely not. It's pretty cold, but yeah, not a strong snowstorm. We have a pollution storm, by the way here. So
Pollution storm.
yeah,
all hands are on deck in Atlanta, Georgia, in the States, where one snowflake shuts the city down. So I'll keep you guys posted on how that goes. Tell us a little bit about yourselves, guys. Give us a short little piece of your background, and I've got a question I always like to kick off these discussions. So give me one or two sentences about your background and how it applies to the conversation.
Yeah, Gaurav, you can.
yeah. So just a quick brief background. Like 8 years back, I was running my computer vision startup where I led the research and development on building computer vision models for background removal in real-time streams. This is something that I'm using even right now on this call, background removal. But at that time, it was not so exciting. After COVID, it became quite exciting for video call solutions to have this capability. So, but at that time, I faced 2 biggest problems while building such a solution. The cost of building an ML model is very high due to the complexities involved, such as the cost of computing on cloud platforms, and also hiring a good ML talent is scarce and costly. So these were the 2 roadblockers that turned out to be the biggest challenges that I ultimately wanted to solve for me, and later on realized that the entire machine learning community is dealing with that. So that's what inspired me to go on this path of solving these challenges.
And you do it with your brother, which is really exciting.
Yes,
So what about
that's the
you?
best part.
I was a particle physicist. Fortunately, I got a chance to work at CERN, where they found the Higgs boson. Media called it with the weirdest name like God particle and many other things like that.
Oh,
But that
wow.
gave me exposure to high performance computing systems and neural networks. And it was fascinating how, using AI, machine learning at a very basic level, even, 10, 15 years back, had a very significant impact on particle physics. And that really, inspired me to work in this field. Then I collaborated with Gaurav, over a project which became our first startup. This is our second startup now. So the first startup, was inspired by an idea that I got from my research days at CERN, which was about distributed computing. To give you a brief about that, generally what happens is when you want to run your AI models, you run this on public clouds like AWS or GCP. Our core idea was, what if you can run your AI models on thousands of crypto mining rigs? Because the same crypto rigs also have GPUs which are incredibly powerful, but they were not designed for AI. They were designed for gaming or crypto. So we repurposed them. It kind of became an Airbnb for GPUs, but specifically for AI. So we had built the entire stack, solved for the computing layer. We ran that for around 4 years, served more than 1 million computing hours. This led to 80% lower cost, and that became the foundation for whatever we are doing right now.
So you were taking available capacity in these crypto based GPUs. I love the Airbnb model for crypto GPUs. I think that's really smart. The compute in general, no matter what it was, from way back to now, there was an inherent capacity gap in the usage, right? Especially for enterprise IT systems, they'd build these big systems and they wouldn't use them to their capacity, and there's so much latent potential and capacity. So that's super interesting.
Is that
Millions of
to deepen almost?
Say that again, Mark.
Is that a precursor to deepen, to like decentralized infrastructure networks where you're using the leftover, the residue GPU of these tow rigs?
That was the I would say original vision, where let's say you're sleeping and your laptop is computing for, let's say, a data scientist in other part of the world, while you get paid for that, and he gets to leverage a much lower cost, you can say, computing system.
It's kind of like SETI that NASA
Exactly.
used, right? So
That's
you
what
could hook up your
inspired me.
computers and all of these astronomical models that needed compute power. You hook up your computer to use it. It's also like, Mark, your wish and your dream as an avid snowboarder to have someone just stretch you while you're sleeping instead of you having to work on your own flexibility.
In a way.
All right, so here's our question, guys. Here's our kickoff question. What do you tell your friends and your family about machine learning, about AI, to kind of pull them into the inner circle, to give them a bit of a leg up, to help them understand it faster than traditionally?
That's an interesting one. So let's say we talk to our parents, and generally at this age, most of the conversations, would always converge around health. And when it comes to health, you should never go to Google, to get an answer, because it will directly lead to the most dangerous
Scare the
things.
crap out of you. Yeah.
Exactly. If you have a cough,
Right.
you probably have throat cancer, something like that. So because there is no brain, there is just enormous amounts of data. Now what if there's a human being which can synthesize all of that data and give you a summary and also filter out bad information. Now that human being is an AI, where you can talk to that instead of just talking to a doctor. You can talk to this guy for the early symptoms, and it will give you a very synthesized but very high quality answer to some of your questions. And the same goes for little kids who are working on maths problem, or someone who is trying to understand physics. So for just imagine having a PhD level human being all the time with you to help you with any of your problems. So that's what AI is, and that's how we explain this to our friends and family.
I like it. Gaurav, do you have any thoughts on
Right.
that? Any additions?
Yeah. Yeah, just an example that comes into my mind, like that Saurabh mentioned about we talking to our parents. Like I used to tell them in a way that this is like your personal genie. Like I'll give you a quick example. Like we have all of our parents every morning they send good morning text messages to their family members and friends. So I asked her, like, you can create a message with Chat GPT. That would be that would sound very professional and very friendly, that you can share with your friends. So it became very easy for her to interact with such chat based bots. That I think has been the precursor for enabling people who could not understand AI. These type of chat based interfaces have definitely enabled access to people who don't need to go about like what is the transformer architecture, how GPT models work, but still they are able to deliver value in form of meaningful outcome for which they don't need to talk to another person. They can talk to a chatbot. So I think that is how like I introduce AI to parents, and similarly friends have started got to know from the sources, the blogs and all. And definitely they ask me like where it is heading towards, what are we seeing in the next year, and definitely the speed at things are moving in this industry. It's very hard to even catch up at times and figure out what might happen in the next year or this year itself in the next 3 months. So yeah.
I wish we'd done this conversation before Christmas, and I went home at Christmas and I tried to have this conversation with my parents and my family, and I didn't use those analogies, and perhaps I should have, but maybe next Christmas.
Those are
But that
great.
time, everything will change by that time. If
Well,
it's
well,
moving
that's
so fast.
well. If everything, just before we get into Neo and that, how if everything's going to change, people very often talk about education and educating people about emerging technologies. How important is it for
Mhm.
me to explain to my family about AI? Is it should I be worried about that explaining it to people, or should I just let them kind of because it's going to be so pervasive in society anyway, they'll find their own way and they don't need me to tell them.
No, I think if you, let's say, if you're the expert among us, among them, you should definitely, kind of give them a warning, because I can bet on this. In the next few years, there will be a lot of misinformation in every single form, in text, audio, video. It's like getting closer to reality. You would have seen, the latest video models by some of these companies. They're getting close to reality, so it's very becoming easier to fool people. So misinformation is going to first, there will be volume of information, and then it will also spread much faster.
And it still lives on
Right.
all the
Yeah.
same problematic infrastructure that is social media algorithms, which tend to promote things that are a little more jarring, a little more offensive, maybe, right? That's the stuff
Wait.
that like scales the audience, that
Intrusive.
increases interaction, right? So we're it,
Exactly.
gas on the
Yeah.
fire, man.
Exactly.
Yeah.
Well,
So we need
let's
to warn people. Yeah, you need to help your family members understand to some extent how to differentiate between real information and AI generated information. It's difficult.
Also, where to draw the
Ah,
line while sharing personal information.
Just a quick shout out to so we have a book club as well as every week interviewing the leaders in tech. We have a book club, and at the moment we're reading The Nexus, and it's all about information networks, disinformation, misinformation, thinking on paper XYZ. Sorry.
that guy is
There
a
you go. Well,
genius.
hey, let's dive into Neo. Let's so we teed up kind of the idea of what we believe you guys are trying to solve, but it's always great to hear in your own words. So what is Neo, and what problem are you trying to solve with it?
So Neo is the world's first autonomous machine learning engineer. The demand for machine learning is increasing exponentially. Every company wants to build their models, or wants to fine tune on existing models. But the problem is it's getting complex day by day. There are hundreds of new research papers, hundreds of new architectures, and new optimization frameworks. Now, to really integrate that and leverage them and use them, you need highly skilled machine learning engineers with years of experience. So the demand has completely outstripped the supply. There are only, you can say, 2 million in total data scientists and machine learning engineers, but out of that, only 300,000 highly skilled machine learning engineers that can really do the job and help you build very high quality models and the entire pipeline. And out of those 300,000 ML engineers, there are only 5,000 that ever became Kaggle masters and 600 Kaggle grandmasters. Our vision with Neo is to provide an AI Kaggle Grandmaster in every company on the planet. Neo automates the entire machine learning workflow, from building your ETL pipelines, cleaning data, to building models from scratch. You can interact with Neo just through a chat and share your problem. It could be that I want to build a credit risk model, and here is my data sets. So it will just take that information and take over the entire workflow and build the model for you. And but we have designed it in a way that you have humans in the loop, so you can always change its behavior, direct its behavior. And when you integrate that within your company, it's like inducting a new employee. Just like a new employee would learn your playbook, your processes, where you store your data, how you clean your data, it will learn all of that, and that will make it more and more human like.
Can we unpack master and grandmaster real quick?
Yeah, what's Gaggle?
Garb, you want to take that, or
Yeah. I can take that. Yeah. So Kaggle is a platform on which ML engineers in a way compete with each other for part. So you can think of it like there are benchmarks today in the industry for AI models, where AI models are competing in terms of reasoning capabilities, mathematical capabilities. So just like an entrance exam, Kaggle is like a competitive platform where ML engineers participate in various different competitions, and the people that win you can say there is a leaderboard score. And when you are basically performing, participating in a competition, the competition could state that you have to build, the task is to build a model for sentiment analysis, sentiment classification. Here is the data set. So you would have to come up with a unique approach to solve that problem. And there is a evaluation that happens along with the validation data set that is provided in the competition. Now, with that validation comes a score, and that score is identified on the leaderboard that suggests that where do you stand with your approach. Out of thousands of participants, you might be in the top 100, you might be in the top 50. So in the top, you can say 100 like scorers out of, let's say, thousands of participants, there is a potential of winning a bronze medal. So as the, you can say, your score increases, there is a high likelihood that you can win a medal. There's a bronze medal, silver medal, and a gold medal. And as Saurabh mentioned, the masters and grandmasters have won a medal in some of the competitions that they participated in. So there is a criteria for defining what a master and a grandmaster is based on the amount of medals that you have won on the
And
platform.
Is
if
this a
you
community? Is this a community-based award of recognition, or is there a committee or people that are outside of the community that determine who gets the medal or not?
So for the competitive medal, so there are different types of, you can say, ways to win a medal. There is like how you have, how you are contributing to the community, how much contributions you have made, data sets medals, how many data sets that you have provided, quality of them. What I'm talking right now is about the competitive medals. So when you participate in a competition, community doesn't provide you a medal. It's more about like how, where do you stand in the competition, based on your approach, what score you got after participating. And that score is not provided by any community member. It is purely mathematical, and it comes from the basis of your approach. You have trained a model, there is an accuracy of that model. Now the higher the accuracy, the higher will be your score, and based on that you can win a medal.
Ah,
it's like
so push the
but
subjectivity aside, purely objective, purely
purely objective.
mathematical. Wow. Okay. All right. So listeners, this
Right.
is super important, right? So if you're looking for resources, right? And correct me if I'm wrong, gentlemen, if you're looking for resources that machine learning engineers, people in this, that would be a pretty good spot to go and say, hey, where could I find a good one? Where could I validate a good one? Not by Mark's opinion, but by math's opinion. I think that's pretty cool.
I just did a quick
Right.
Google search as well, and there are about 2,000 chess grandmasters. So there are, in fact, my
More
maths is
grand chess
four,
grandmasters.
four times as many chess grandmasters are there are machine learning Gaggle grandmasters,
Yeah.
which is
Right.
um, pretty surprising in this world. How many do you think we need? I know it's a bit of a stupid question, but mate, in the next 5 years, we have 600. How many do we need to keep up with the demand for AI? Do you think ish?
By 2030, there will be almost a million AI native companies. Uh, when I say AI native companies, what I mean is you would need a 3 to 4 machine learning engineer kind of team in your company, building your own models. Because now the trend is a lot of these companies have so much data that they can't leverage unless they fine tune these models or build their own models. You can't just use OpenAI for all the different use cases. So there will be 1 million AI native companies, but there are only 600 Kaggle Grandmasters today. So the vision, with Neo is, can we provide a Kaggle Grandmaster for all of these companies? So imagine you have a, not even a PhD, beyond a PhD level expert in your team that works for you 24/7 for a fraction of the cost, which would have costed you millions of dollars earlier. Now, that's one. Second is just to complete the loop on master and grandmaster. One definition of Kaggle grandmaster is you have to win 5 gold medals in 5 live competitions. Once you are able to do that, you become a Kaggle grandmaster, and that's why they are so few. And so OpenAI, recently what they did was they created a benchmark for agentic systems like Neo. So Neo is a multi-agent system. So they created a benchmark for these kind of system, and the benchmark was again on Kaggle competitions. They What they did was they ran their model along with different agents on 75 Kaggle competitions. These are like some of the toughest problems. It can take almost a month sometimes to solve one problem. They are so complex. Now, OpenAI, with the best model they had at that time, it was in October 24, just 3 months back, with the best model O1, they got a score of 16.9%. Neo got a score of 26%. So Neo was able to outperform OpenAI at a benchmark that they created.
That's powerful. Congrats, guys. Wow, that's
Thank you.
impressive. So let's talk about and I in my research and our pre-show discussion, the idea that what Neo can help engineers automate are some more of the basic tasks, the foundational tasks of building these super complex models. So let me throw an analogy at,
Grunt
at
work,
what's that?
the grunt work, I believe it's on the
Yeah.
website.
Right. So, but there's value in the grunt work. So I don't like to use that there's value in the little bits and pieces, right? So if we use an analogy like I'm an airplane builder, right? And instead of me bending the metal to make the wings and riveting these things in place and screwing on bolts to make the jet engine work, I can put automated entities in place to help me with that while I figure out how to fly the plane faster, better, smoother, cheaper. Is that reasonable?
That's a good analogy. Yes. If you're an airplane designer, you would rather focus on making a faster plane or a much sexier plane instead of
Safer.
spending your time on exactly. You can go for 10 times bigger goals in life because now you don't have to deal with bolts and screws or taking care of engine oil and all of that. So all that grunt work which you would today give to interns, or you can say a lot of junior level engineers, can now be automated.
Right,
It,
right,
it,
yeah. A lot
yes,
of the yeah, there is a lot of grunt work in machine learning space also, like uh, data processing, exploring exploratory data analysis, wrangling with the data sets, iterative experimentation, sandbox environment setup, management. A lot of these things can be highly automated while still creating a generalized system which can generalize on a lot of different problem statements. That's what Neo
setting up,
enables,
you know,
while being
yeah,
smart enough.
setting
So
up
state
GPUs like we discussed earlier, to build your own uh, uh, to deal with different clouds, different GPUs, fit your model inside those GPUs, containerize them, learn orchestration among all of that. So that's first. It's a lot of dirty work. It's a lot of grunt work that they are forced to do right now, and that wastes a lot of time. And generally, what happens is it's not a one-time thing. You have to keep on doing that. You have to scale up your systems, and these things tend to come in your way when you really just want to focus on building better models and you want to be closer to your customers.
So let's stay with our airplane analogy again, right? So in order for me as a pilot to trust autopilot, push the button and say, hey, this machine's going to fly the plane. How are you building trust with the people that are going to lean on your systems? Are we back to objective, demonstrable math, or are we trust us subjective? Yeah.
Exactly. That's a very good question and a perfect analogy here. So, uh, to trust an autopilot, you would look at its history. Was it able to first? Uh, did they test it out? Let's say with 1 million simulation runs, or they were able to test it out for, let's say, 10 years in real life scenarios. So what Kaggle has done for us is these are some of the toughest problems given by these big companies like Tesla, OpenAI, some of the hedge funds in financial markets. They've thrown out these problems, and it's because of this OpenAI's benchmark, it has become really objective, and that's why this score of 26% really helped us in getting our initial traction. It really resonated with a lot of, you can say, machine learning engineers and heads of AI data science heads. They like some of the biggest brands on the planet. They signed up on our waitlist purely, I would say, because of this validation, this objective validation of the score.
Al- Along with that, like what happens, like in case of autopilot, yeah, like Saurabh mentioned, there are millions of hours of learnings that the system has. Like as a pilot myself, I might have 10,000 hours of flying experience. When I have this much experience, I learn on each hour of flying the plane, when how to land, when to launch the gears. So these are small things which as a human I learn. The same way Neo, being an autonomous ML engineer, is capable of learning from the experiments that it performs. And with each experiment, it is learning. It is storing that in its memory, and that ultimately leads to a more powerful system as it progresses through these experiments and Kaggle challenges which we made it participate in.
I'm going to ask a silly question, please. When it's learning from previous behaviors, how does it deal with mistakes that it's made?
Definitely, like there are code level issues that it can debug. There are issues around how to wrangle and perform data exploration, how to analyze the data, how to do feature engineering. There are many steps in the ML engineering pipeline at which it can fall apart. Now the idea is this, and why it falls apart is because unlike an AutoML pipeline where you have a standardized workflow where everything is templatized, here we have a system which is presented an unseen problem. Now it might have to work on a data set that it has never seen before. It might have to work with an model architecture which it has never even thought about, like what how many parameters are there, how many dense layers are present in this neural network architecture. It may not have that information prior to getting started with the task. So there are a lot of variables which can which can lead to breakages in the pipeline. Now the idea is this: with so much experimentation and the learnings that it has gained, it is able to generalize across different scenarios, where even if I present a model architecture which it has never seen before, it still has an understanding of how to analyze the architecture and how to go through the process in a step by step phased manner. And that is what we call as multi-step reasoning, that reasoning enables the system to perform exceptionally well at such complex challenges that we
And
presented to
I
it.
would also add one more thing to solve this problem. When we started out, like 6 months back on this problem, we started with a singular agent flow. So what we did was we created an agent which was trying to mimic the behavior of an ML engineer. And agents tend to hallucinate because LLMs behind them hallucinate. So one of the ways we solved, this problem was instead of a singular agent, we created multi-agent system. With that, we are trying to mimic an entire team. So what happens in reality is whenever there is a problem, a machine learning problem, a single engineer is not solving that problem. It's a team of data scientists, data engineer, ML engineers, ML researchers, all working together with a strong feedback loop among themselves to solve a problem. And that's what we are building with multi-agent system. And when we switch from single agent to multi-agent, our you can say error rates reduced drastically, hallucinations reduced drastically, and we were able to get much more accurate results.
So going back to just the idea of this has been a thread that Mark and I have talked about for years, the idea of interdisciplinary teams bringing something really special to the table instead of having a single threaded entity trying to figure out a problem. It's this feedback loop between this, dare I say, nexus of resources, right? Gentlemen, it's time to stretch. It's time to get ready for your gold medal test. This is Mark's 5 questions in 30 seconds test. So guys, we're going to put 30 seconds on the clock. Mark has some quick yes and no answers. Let's bounce back and forth. I don't know who feels spry. Who wants to handle Gaurav? You want to handle the first one, and we'll bounce back and forth. All
Uh,
right, here we go. Are you ready?
yeah, like,
Never,
okay,
never been attempted
okay.
before on a podcast anywhere in the world. Let's go.
Stay tuned. Here we go.
Is the clock up? 29.
Clock is up.
Um, question number one. What is the best AI assistant for the general non-coding population?
Non-coding population. General AI assistant, I would say, right now in my experience, it
Claude.
is
Okay.
Claude.
Question number two. What is the best book on AI, fiction or non-fiction? Doesn't matter.
Okay, that's an interesting one.
Nick,
I don't have
Nick,
any
Nick,
specific one to
Boscron's
answer right now,
super
but
intelligence.
Okay. Question number three. What will AI
yeah,
agents use as currency?
Dogecoin,
currency.
if Elon Musk would promote it.
Reasoning,
uh,
I would say. Reasoning is the currency.
but I think just on a serious note, I think there should be a new currency backed by compute and contribution from
Yeah.
developers. So imagine a decentralized currency specifically built for AI, but it is backed by how much. So just like in the crypto in the Bitcoin world, the early developers who contributed got a share of those early Bitcoins because they contributed through their coding, you can say, talent. Then there are people who are contributing through their computing, through all the GPUs, crypto mining rigs. Similarly, what if you can do something for AI? And I think eventually someone will build such a network where specifically for AI, and these agents then can use that currency. Just an idea.
Okay, so
What
just as a judge here, Mark, we failed tremendously at delivering all the answers and the questions in 30 seconds. Just your interdisciplinary feedback loop at hand. Please continue.
well, I'm just going to ask you the two questions because I've got to close the loop. It's I won't sleep otherwise. Question number 4: Hollywood doomed by AI or reborn?
I've been thinking about this.
I would say reborn. I
Yeah.
would say I see on the positive side. I believe there's a whole lot of creativity that would be boosted with AI. So
Reborn.
The way
Nice.
I look at Hollywood and any other art form, I would say it's a long answer. I'm not sure if I'll be able to finish this in 30 seconds. But my view is entirely driven by history, where Michelangelo, they were artists, sculptors before Michelangelo. And if you were to build an AI, based on all the training set, all the data that you would have collected from the previous generation of artists, you would have built something really beautiful. But but the thing with Michelangelo was he went far. He crossed boundaries. He went after cadavers, at night to really understand deeper levels of anatomy, and that gave him so much insight that when he built his first, at the age of 19, when he built Hercules, and later when he built his David, you could actually see the expressions, the nerves, coming out of those marble pieces. You can only do that when you go beyond and cross these boundaries. So the problem with the AI systems would always be about two things. One, it will always follow the rules and the bound within the boundaries of the entire training set that has been given. Second, it's about taste.
mhm.
So there are, the greatest artists of our time and in the history, they had a very nuanced and a very different type of taste. And I don't know how to create a mathematical equation to describe taste. So based on these two things, I would say uh, people who are really great at their craft, now they will become superhuman. Instead of, like Christopher Nolan, instead of releasing one movie in 3 years, probably he can now do more, and we would love to see that. uh, and so it will increase volume, but people who are mediocre, their jobs can be taken away.
You've just answered question number 5 as well as being giving us an incredible answer to number.
Talk about superhuman.
Well, yeah, question
Are
number
you
5.
using a model in the background? What's happening over there? Yeah. Well, hey, so thanks for participating in the hot buttons. You know what it's time for, guys?
It's
You
another
know what it's
one.
time for? It's time for TOP News. All right. So it's CES week, right? It's
Oh
CES,
yes.
all kinds of stuff on in
yeah.
Vegas. Specific to NVIDIA, we want to kind of focus on some announcements that NVIDIA has put out there. The first one that's super interesting, guys, that I would love to get your thoughts on. They announced a new personal AI supercomputer called
Digits.
Digits.
Oh
Digits,
man.
right. So it can support 200 billion parameters, whatever the hell that means. Guys, what is Digits,
Yeah.
and is it going to do anything
Is
to
it good?
influence the AI revolution?
I couldn't personally spend a lot of time on digits, but I spent just 10 minutes, through the announcement and everything. My belief is it will first, really, I mean, imagine, an exaflop supercomputer, which would have taken, a house like this multiplied by three, now in your hands. What what are the things you can do? If you're brilliant, if you're great, if you have some really innovative ideas, there is no excuse now. For $3,000, you get a fucking supercomputer with one exaflops. You can do so much. And I'll tell you, all the brilliant innovators in the world now get their shot. They can build things. So imagine, sorry, I'm getting very excited about this, but there are
No,
three
roll with it.
bottlenecks. There are three bottlenecks, always: data, compute, and talent. We are solving for talent with Neo. Now, if you are a good Python engineer, a regular software engineer, you don't have to, go through the complexity of machine learning engineering. Using Neo, you can bridge that gap. Second is about compute. So Digits is solving that. So with Neo and Digits, the things you can do now is is going to like blow up everything. Like in next 3 to 5 years, it's going to be the best time, in the entire history of our planet. There will be scientific revolution. It is a new renaissance, I would say.
Scientific revolution and then political chaos
Oh
potentially with
yeah.
people with these powerful
Yeah,
computers
yeah.
trying to re-engineer messaging. But we'll save that for another episode.
we just
Gaurav,
we just
let's.
need to we just need to buy Canada and Greenland. That's it.
Ooh, okay. All right. So that's a great answer. I appreciate that. That's great context and almost inspiring context as well. But Gaurav, let's talk about this. So in
Yeah.
1965, there was a guy named Gordon Moore that decided to predict how quickly
Moore's law.
transistors would
Yeah.
double over time, right? So the Moore's
Right.
law, 2 years doubling of transistors. The CEO of
Double.
NVIDIA now says Moore's law is bunk. It's but what could a common
Yeah.
metric, a new common metric to define the progress of AI supercomputers moving forward?
Right. I think, like, in fact, this was actually something that was coming in my mind while Saurabh was answering the previous question. That just like Moore's law, there has to be another law which would definitely soon somebody would write about it. That the number of parameters in the model triples every year. So earlier we had 8 billion parameter models, then 32 billion, 64 billion, more than 100 billion, now 200 billion that could run on your desktop. The thing we would definitely see is, so number of parameters definitely doesn't justify the intelligence of a model. There has to be a lot of the things, as have been shown by other researchers in the past also, is that there has to be very high quality data which goes in hand with the number of parameters. But definitely having more parameters gives the edge to a model for generalizing to a lot bigger data set. So that definitely enables a model to act like a super intelligent system where it can focus on 10 different tasks instead of just being a narrow AI. It feels as if it's like a general intelligence. So bigger models definitely tend to offer this type of perspective, and that could definitely be, in my personal opinion, number of parameters can definitely lead to a signal that how intelligent the model is, and that could be considered as the unique value, for just like we have had Moore's law
So
for
as in the
transistors.
number of parameters, like we referenced in digits, supposedly 200 billion parameters, right? But it's also like you said,
Right,
it's a garbage in, garbage out situation. So Mark, as the premier
right,
snowboarding athlete that he is, he's got all of these pieces and parts that work very, very well. But if he goes down the mountain the wrong way and runs over rock and avoids snow, he's not going to be a great snowboarder, right? So you got to have the right stuff that's using these things, right?
right, absolutely. Along with that, one more thing that could definitely be that definitely act in pushing this, you can say, stage of AI transformer based architecture models is memory. Like this is a concept which came in an year back only, I believe. The idea is just like how a model can memorize concepts uh, beyond the training data on which it was trained. Now that leads to learnings in real world scenarios, just like humans. Like if as a baby we start to crawl, and then step by step we start to walk. If you see reinforcement learning agents, there are millions of iterations after which they start to learn. But why are they taking millions of iterations? Why are they not able to walk in, let's say, the next the fifth iteration itself?
Can I pause? Can I pause on that?
The idea.
Sorry to
Yeah,
interrupt. Can I pause on that? What
yeah,
do you mean by concept?
yeah.
Can you relate? Like, what is a concept that we would memorize or a machine would memorize?
Like for example, in case of reinforcement learning, there is a concept called as reward functions. Like let's say I get hit by a car while walking on a road, I get negative reward. If I am able to save myself, I get a positive reward. So the the idea, the concept is, then how do I save myself? So that is the way it memorizes concepts, and in a way, this type of system can learn in real world scenarios. And definitely a very large model which already has been trained on very huge amount of generalized data, high quality data, along with the capability to memorize concepts while as it interacts with the world. can potentially lead to a general intelligence type of system.
So how good? So a metric could be how good that model, that system, takes in a concept and applies it to becoming more efficient at what its job is.
Right. That's what actually made the core difference between the GPT-3 API, which was there before ChatGPT, and then ChatGPT came up with RLHF, reinforcement learning with human feedback. So that provided a reward function, which enabled the model to learn what to do and what not to do while during the training phase. But the idea is models cannot be, we cannot keep training because training is costly. There has to be a new way of making the models learn in real world scenarios when the training data has been exhausted. uh, what to do now, let's put it in real world scenario, and then it can go through certain experiments and come up with what it should not do.
Could models be intrinsically motivated to get excited about being rewarded?
uh, Yeah, I believe so. We can
That's interesting.
that's more on the side of nature of a model. Yeah, like we as a human have nature. Every human has a distinct nature where we get aligned towards. Like someone might have a sharp nature of understanding things quickly. Somebody might be a slow learner. But that's how our different brains work. Similarly, a model can be tuned to like focus on positive reward function. That's actually you can think of it like there was a concept called as chain of thought reasoning that was introduced a few years back and was implemented again in O1, which enabled it to reason very well compared to previous models. So chain of thought was implemented right in the data set itself. The data set was presented with examples to the model so that it can learn on these examples, like how to think in form of a chain of steps. So just like that, we can potentially create a data set that could uh, make the model align towards focusing on positive reward. And that could lead to potentially better or quick learning
It's
for the model.
super interesting. I want to wrap this one thought up, and then I think we want to go over the carryover question for Mark. You could lead the charge on that. But it's almost like the relationship between coaches and athletes. I coach lacrosse, and at multiple levels, and some players are motivated if you get in their face and get really, hey, what are you doing, whatever. And then there are other people that are motivated in different ways that might not work for them. So similarly, what you're saying is these models can be set up to take in a particular reward mechanic better than another. Is that right? Am I grasping that?
Yes, we can potentially drive the nature with the with data set designed that way. At least we have not tested that, but I believe with providing the right set of examples, with a lot of examples, we can potentially make a model that can be tuned towards this type of. We are basically changing the nature of the model. uh, that's what we call today as thinking, like O1 is thinking. So it's doing chain of thought reasoning and reinforcing itself with on each iteration so that it can come up with better tokens.
Amazing. This is fascinating stuff. Holy cow. Like,
I mean,
yeah.
I'm sorry, but when you asked that question about could the AI model learn to intrinsically chase rewards, you had a little glint in your eye. And what was the book, the best book on AI that we should read? Super Intelligence. I know where you were going with that question.
Fair.
But
Speaking
we
of
won't
questions,
open that can of worms today.
yeah, Pandora's box all over again. No. So, all right. Speaking of questions, carryover question. Let's hit it. Guys, this has been a fascinating discussion. Thanks for rolling with the punches of the new segments and everything. And I think there's a lot of great nuggets that our listeners are getting
And
out of this. And yeah,
just to add, few words, for that question, would there be a new law? I think for all the contribution that Jensen has done, I think we should have a new law with his name, Jensen's law. For just for you,
Yeah.
for a
so we have an
combination of
NVIDIA
full-time
proponent on
license.
the interview session today. I like it. No, he's done it. Yeah,
Sounds like someone wants to get in a room with him.
we have sent him some notes to be on the show. Maybe it's his time now. Perfect timing.
With his leather jacket.
Yeah, well, it'd be amazing.
Let's tie it together, Mark. What do we got?
Well, and tie it together, I'm actually going to throw a spanner in the works and change the question, because I think with the hot buttons were so on point that they've answered the question, because it was really about how this new generation of creatives will live with AI. So I'm going to change the question because I believe rather it's a particle physicist. Next week we have X Prize on. We're talking about quantum computers. In the past, one of the big take homes for me from all the quantum conversations we've been having is there aren't any quantum developers, there aren't any quantum engineers, and there just seems to be this dearth of developers across emerging technology. And yeah, and next week we have X Prize coming on who are talking about how they're trying to fix that in quantum. Do either of you two have any views, opinions on quantum and AI and how you see the two paths going ahead, merging, not merging, in the imminent future and the more long term future?
Right. Like just to start off on that, like I recently got a chance to learn about the development that Google presented in the keynote for quantum computing, and that definitely turned out to be pretty wild implementation in quantum physics, quantum computing. uh, the ability of a system to perform so many amounts of multiple simulations in parallel, iterations in parallel, in a way to come up to a solution, uh, that ultimately I believe is the key to uh, getting super intelligence, having so much amount of compute available. A normal computer, we can increase flops, we can keep on adding transistors, but definitely there would be unless we change the architecture, unless we go beyond transformer architectures, bigger models would need more compute. That would be costly, and beyond a certain limit, we would face issues with networking, because we would have multiple GPUs connected to each other over network latencies and all those things. So the and this I think also is a perspective that as a human, when we are tasked with a problem, if we have a capability of thinking about multiple solutions ahead of time, then we always come up with the best solution if we get enough time to think. So similarly, a quantum computer can basically compute multiple iterations in parallel. That gives it the opportunity of solving the solution in a very quick time. And a model which needs which is just spitting tokens without any reasoning. If it is given the capability of thinking multiple iterations in parallel, then it can come up with a better solution compared to what it might have come up in the first scenario itself. So quantum computing can, in my opinion, definitely help AI go beyond the phase of where it is as just as a
It's like
chatbot
having the
today.
superpowers of Doctor Strange. You can simulate all the possible worlds and find the one where you can live. So I think that's the exciting part, I would say, about building a quantum computer. Like Gaurav, rightly said. Let's say you're solving a scientific problem where you have to build, let's say, a new form of let's say material or new alloy. Now, generally, it's a very experimental job in nature. You have to go through so many combinations. What if you can simulate all those different combinations in like 5 minutes? That would this impact it would have on this scientific exploration of new materials, research. When you're solving, you can say, medical problems, you can simulate all those different paths, and this will accelerate a lot of things, not just you can say in the field of energy, in material science, but also in the medical science. And but the cons, these are all the pros of, I would say, pros of quantum computing. But one of the problems, I think, which world is not ready, I would say, yet, is when quantum computers are able to solve encryption. What happens to all the blockchains that we have built so far? What happens to the highest encryption standards that we have built if quantum computers can break that? So that's one area where I think,
Yeah.
as researchers, everyone should invest a lot of time in building much more robust, you can say, encryption systems before we launch. We push the nuclear button of quantum computers onto the world.
So just a quick shout back to previous episodes. We had the post quantum cryptography lead from IBM. Apparently, we have till 2032, I think, until all shit hits the fan. So That's great. So great conversation, guys. What about a carryover question for our next guest? It could be on any topic, any subject. It doesn't have to be AI. It doesn't have to be quantum. It doesn't even have to be tech, philosophical, whatever you want.
Yes.
One. Okay.
I have a philosophical one. Yeah, like maybe Saurabh can add his ones. Like straightforward question: are we in a simulation? And is there a way to figure that out in the next 10 years, maybe the next decade? Would we be able to figure that out? Like if I would have been Mario in the Mario game, there's no way I can come out of Mario game.
Well,
Can
if
I at
you're
least
Once
can I
we
at least
realize
get
if
the
we are
you're
in
cheat
a
codes?
simulation,
if you're eating the mushrooms, you're definitely in a simulation.
cheat codes.
And if we can't hack out of the simulation, can we at least get the cheat codes?
I love it. I love it.
Hey,
Gentlemen,
I have
thank
one.
you so yeah,
I have
gentlemen,
one
thank you so
question.
much for
Okay.
oh, sorry, go ahead.
Yes.
I just have one question, for the next audience, especially because they're from quantum computing world. Uh, like based on the announcements by Willow, the Google's quantum computer, one of the things that came out was it was able to compute something that would have taken billions of years for a supercomputer. It was able to do that, like I think in 5 minutes or something. And one explanation, which is really weird and crazy right now, is that it was able to go through multi worlds. So it's a multi-world universe, and some of the people are saying that it's an evidence that we live in a multi parallel universe kind of scenario. Now, the question, for the next, you can say, folks are, is there any other explanation uh, that how was it able to, really get the right answers within those 5 minutes? Is this about, uh, you can say, superposition of different scenarios, uh, and collapsing onto a reality, or is it something really fundamentally different that is happening at the quantum level, which is actually able to deliver those results?
great question.
Great question. I love it. Gentlemen, thanks so much for joining us. We'll be spreading the good word about Neo. Keep up the great work and keep us posted on how things are developing over time. And maybe in, a couple of quarters or whatever, you guys pop back on and give us an update. But thanks so much for joining us.
Yeah.
Awesome. Thank you so much. Have a great new year.
Thank you.
Take it
Thank
easy,
you.
guys.
You too. Bye bye.
Thank you. Bye.
All right. Disruptors and Curious Minds, you are now backstage with Mark and Jeremy as we slow our heads from melting about the idea of parsing off compute into multiple multiverses to have some compute happening over here, some happening over here, but it's all at the same time.
Well, we spoke about that on book club when we were reading the which was Quantum Supremacy and maybe The Order of Time. We spoke about that tunneling between worlds with information, and it's a great question that we can ask next week's guests. How are you feeling about Neo, AI, engineering, and what you've just experienced and learned, Jeremy?
It's really interesting, and it's not it's a concept that's been throughout time. I think the idea of like automating and optimizing workflows that let us think about higher order things. I think is the important thing that landed with me, and Neo has apparently figured out a way to automate in a trustworthy way, in an objectively provable way to engineers to offload certain tasks that they'd rather not do, and they can focus on solving bigger and more challenging problems. I'm excited. I want to learn more about, I want to see that stuff in action. I want to see someone use Neo to offload some stuff. And then as companies start having machine learning employees on staff to deal with these large data models and automating them and pointing agents to doing things, right? I don't know. What did you learn? What did you take away from this? And what did you not believe today? Did you not believe anything today?
Well, just on your point there, I saw a few videos which I'll put on the show when I write it up, thinking on paper XYZ, about people using Monster API, which was their first company before Neo, and they're using it to offload some of the work. When I came into this doing the research, I was very surprised by how few engineers there are. I mean, they spoke about Kaggle Grandmasters. I'm unsure what the difference between a Kaggle Grandmaster and one of the other 5,000 who are good. So I don't know what somebody who's number 5,000 could do as opposed to somebody who's a grandmaster. I mean, what the real difference is in their abilities. So when you're speaking about the greater creative endeavors, I think that just as in real normal life away from AI, in any company, you get people who are tasked with creative thinking and people whose job is the mundane and the repetitive and the what's the word that they said that you didn't like, the
the grunt work.
grunt work. And it, I don't understand why there are so few engineers, and it must be to do with that grunt work, and maybe it's just not much fun. And if you are a developer of any kind, there's more job satisfaction to be had elsewhere. Perhaps there's more money to be had in AI, but maybe there's more job satisfaction to be done elsewhere. And Neo taking away a lot of that, I see it as almost inevitable that it brings more people in, and we get more of those developers that the world so desperately needs. Apparently, like if there's going to be 1 million AI companies, one thing about making predictions about the year 2030, that he says that there's going to be 1 million AI companies, you could easily triple that, couldn't you? Quadruple it? I don't know. So
yeah, well, how many startups have the AI nomenclature tied to them, right? And are they really AI, or is it just a little bolt on that this but AI, right? So you have a lot of that. I think a callback to Julio Otino, right, with Nexus and Nexus thinking, and there are people that thrive in these divergent thinking spaces, and there are people that prefer more of the convergent mindset where they could be really 100% the best at one particular thing and do that one particular thing. And I think we're moving towards this polymathic tendency of society and of individuals trying to do interconnected things, I think. And people are starting to be more open to that. The gig economy itself
right, and using
points
AI
into that. Right.
reality, yeah.
Right. Well, good stuff. This has been great. Hope you guys have enjoyed this new format. We're going to continue experimenting with it.
What didn't you believe? You asked me if I didn't believe anything, so that makes me assume that there was something you didn't believe or you weren't short of. And as I just say that, there was maybe one thing that was interesting that I don't know if it's not if I believe it or not, but he said the world wasn't ready for quantum computers, and I wonder if the world is ready for AI of this degree.
I don't think the world is ready for AI. Like I think, but we can't, we talked about it being a genie, right? And, we can't stuff that thing back in the bottle, man. And, there's a lot of stuff that freaks me out a little bit about AI and, offloading certain things. We've talked about this a ton. Like if we push the easy button, and we're susceptible as humans to pushing the easy button, we're optimization machines. We want to try and find the shortcuts to everything in our thinking and all of that. And if we push this AI button more than pushing this brain button, like, are we going to lose our ability to creatively think and all that? So that's always running in the back of my mind as we have these discussions. And I'm not saying AI, there won't be some benefit to it. I think there's tremendous benefit to it, but I think we got to be careful. That's all I have on that.
Just to be clear, though, Neo aren't about making it easy. I think about making it more difficult, where you've really got to be very, very, very passionate, and it's a lot of work and a lot of thinking. You need to be very smart and very engaged and very into subject, and you can delete that out, edit that out, Jeremy. That's your new job, Ali.
Oh my gosh. Well, hey guys, thanks for listening. Thinking on paper.xyz. Tell us how we're doing, man. We started this show for us, but we're making it for you. We want this to be a valuable tool for you guys to understand what's happening in the tech space and how it affects us as humans, our relationships, our families, our jobs, all of that fun stuff. So let us know how we're doing. We also have book clubs. Stay tuned. All the info is on thinkingonpaper.xyz. Check us out. We'll see you soon.
Stay disruptive.
Be curious.
Keep thinking on paper. See you next week. Bye-bye.